Let's move on to question number 3. How do you calculate formal charge? So first, I'm just going to write down the definition of formal charge. And basically, this is the charge associated to an atom in a molecule. So we can use the following equation. So formal charge is equal to the number of valence electrons in the atom minus, in square brackets, the number of non-bonding electrons plus the number of bonding electrons divided by 2. So this is because each bond contains 2 electrons, and if we want to find the formal charge of one of the atoms, we need to divide it by 2 to find out how many electrons are associated with that one atom. So I'm going to have an example here. I'm just going to draw out like a hydrogen that has 3 methyl groups and also a single bonded oxygen. And I want to find out the formal charge of all the atoms. So let's say nitrogen, oxygen, and also carbon. So let's do oxygen first. For oxygen, its formal charge is equal to the number of valence electrons in an oxygen atom. So for oxygen, that would be 6, minus the number of non-bonding electrons. So let's look at our oxygen atom right here, and you'll see that there are 1, 2, 3, 4, 5, 6 non-bonding electrons, or like valence electrons, plus the number of bonding electrons divided by 2. So there's a bond here that contains 2 electrons, so I'm going to write 2 divided by 2. So it's going to be 6 minus 6 plus 2 over 2. So that is 7. So 6 minus 7 is equal to minus 1. So for oxygen, there's a formal charge of minus 1, so I'm just going to write a negative charge beside the oxygen. So now let's do the same thing for nitrogen. Its formal charge is equal to nitrogen's valence electrons, which is 5, minus the non-bonding electrons. So you see that this nitrogen has no lone pairs, so I'm going to write 0, plus the number of bonding electrons divided by 2. So that you can see that there are 4 bonds attached to nitrogen, and each bond contains 2 electrons, so therefore there are 8 bonding electrons divided by 2. So this is saying the same thing as 5 minus 4, which is plus 1. So now I'm going to write a plus charge on my nitrogen atom. And then lastly, let's also look at the formal charge of carbon. So the number of valence electrons in a carbon atom is 4. So we can just look at the one carbon atom. You'll see that there are no valence electrons, no lone pairs of electrons, so I'm going to write 0. And each carbon has 4 bonds attached to it, so that's because there are 3 hydrogens, and then each one has a single bond to nitrogen. So again, I'm just going to do 8 over 2. So this is the same thing as saying 4 minus 4. So each carbon has a formal charge of 0. So we can also double check and see if this makes sense. Nitrogen has a +1 charge and oxygen has a -1 charge. So the entire molecule is neutral. So let's see the answer from our junior tutor. The formal charge of an atom is the charge assigned to an atom in a molecule, assuming that electrons are shared equally between 2 bonding atoms, regardless of relative electronegativity. So determining the formal charge of each atom in a molecule is important in order to determine the electron distribution in a molecule. Combining all the formal charges of atoms will also result in the overall charge of the molecule. Moreover, in determining the Lewis structure of a molecule, the structure with the most formal charges of 0 on atoms is the more stable structure. In calculating the formal charge, we use the equation below. Fc equals valence minus non-bonding electrons minus bonding electrons divided by 2. So here they have an example with the nitrate ion, and they drew out its corresponding Lewis structure. So first they calculated the charge of the central nitrogen. Nitrogen belongs in group 15, has 5 valence electrons on its outermost shell. Because there are no lone pairs attached to N, the non-bonding electron is 0. So that's the same as my example as well. But lastly, since there are 2 single bonds and 1 double bond attached to it, the number of bonding electrons are 8. Calculating for the formal charge of nitrogen, we have +1. And then they also calculated the formal charges of each individual oxygen atom. So they first looked at the top oxygen, has a valence number of electrons of 6. There are 6 electrons in the lone pairs. There's 1 bond with 2 electrons, so they got -1. If you look at the leftmost oxygen, it also has a -1 charge. But if you look at the oxygen on the right that has the double bond, it has only 4 electrons participating in the lone pairs, and it has a double bond, so there are 4 electrons involved, divided by 2, and this formal charge of the oxygen on the right will only equal to 0. So then they took the sum of all of the formal charges that they got, so +1, -1, -1, and if you add it all up, you get a resulting charge of -1 for the entire molecule. So this corresponds to the overall formal charge of the nitrate ion. That was a good example and explanation, so this solution is correct. So now let's move on to question number